Right. So we are here at question number 9. So this questions actually this question is not necessarily be important for your level at your new syllabus because this contains some part that's missing from your syllabus actually. Okay. But however, we can discuss this a bit to understand this flow diagram. So this is a final year project to combine several processes and to make an efficient industrial environment. Okay, so here they have given this one. So this is a final year project, and ours are here. So they have used two natural raw materials and M. So they have used 1, 2, 3, 4, 4 manufacturing processes. So this is very good, right? Because all are interconnected and they have several products, in fact 9 products, so which is very good project actually, because they have used 4 major industrial processes and to get 9 products. Okay, so let's first go through the flow chart first. So these are 2 natural raw materials, so this could be air, so we can just imagine this could be air, and this could be like any other, like let's say like limestone for an example, maybe we don't know, limestone, and it could be seawater, and it could be something else. What else it could be? Seawater, limestone, air, and it could be some oil for soap production. We use vegetable oils, fats and oil, anything. So it can be all those things which are naturally available. So this could be one of these, as I can remember. And you do some manufacturing processes, M1 and M4 here, but M4 is added with another product P3 from one of the other processes. So let's try to find what is R1. Okay, so we do something for R1 and which gives 2 products. This is the point, 2 products. But I see here a salt is added to lower the melting point of P1. So in our extraction process, for an example, in our extraction process of sodium, normally we use the electrolysis process of NaCl, right? Fused chloride. And since the melting point is very high, we use this with calcium chloride to decrease the melting point. So this salt here is surely calcium chloride. So which gives me the idea P1 should be NaCl that is obtained, right? Because NaCl added with the salt, we produced one as sodium, and also we produce one of the other important byproduct of this, which is Cl2. Okay, so here this P4 is used here as well, so this P4 could be Cl2 here, P6 could be sodium. So if this is NaCl, this should be the manufacturing process is formation of salt in solvents. So this R1 should be then seawater, right? Because you have seawater, so you produce salt, formation of salt, we can write formation of salt, and in solvent, so you get NaCl. And what is the other one? This could be brine or the mother liquor solution, right? P2 is mother liquor or brine solution. It could be combined to another one, right? If you can remember, we can combine this to another industrial process, right? So it's very effective, I would say. And you have NaCl, so you add water. So if you can remember, so here you obtain NaCl soil, so you add water. And here it's, I think, the electrolysis, right? Because when you do the electrolysis of fused NaCl, you get sodium. But when you add water, so you have H plus and OH minus ions. So this should be NaCl aqueous. So NaCl aqueous is used to manufacture of NaOH, because that is when you obtain this product Cl2 as one of it. Okay, so P3 is NaOH and Cl2, and you get P5, which could be other additional byproduct, which is H2 here in this case. Okay, so this is a natural substance, right? Raw material, and you use NaOH and this natural substance to get something. So can you remember what is this part? Is there in our syllabus where we use NaOH? What is it? Can you think about that? So if you can remember about these natural products, in fact the natural raw materials, when you have oil, we heat this with NaOH to get, what is this process? This is formation of soap. So this is soap production. So first part of the soap production is a saponification. So we get this. So we get, this should be production of soap. So we get soap, as well as we get glycerine. So one of these is glycerine, right? One is soap, one is glycerine. And here they say we mix P3 and P4. So NaOH reacting with Cl minus. So basically this should give NaOCl. So if you remember the reaction, right? So this is a good bleaching agent. This is another industry that you can use to combine. In fact, there is more industries that you can see here, right? Right, so this is the complete picture of this. Okay, so think about the point that we started. So there are not much of a big processes that is involved. This simple piece of information was enough. So if you know the production of sodium, you will eventually know we add calcium chloride to decrease the melting point up to 650. So you can find others as well. So P2 is used to produce a halogen that exists as a liquid at room temperature. So what was P2? So mother liquor. So you can imagine. So we use this to produce Cl2. So it is very normal. So P7 is used as a bleaching agent. Yeah. So we have NaOCl. So it's used to produce bleaching agent, right? So P8 is used daily to maintain good hygiene. So here it should be changed here. So P8 should be soap. P9 should be glycerin. To confirm that, they have given this piece of information, right? So identify two natural raw materials. So R1 is seawater. So R2 should be oil. And identify for manufacturing processes M1, M2, M3, and M4. Oh yeah, so M1 is manufacturing of salt, and M2 is manufacturing of NaOH, M3 is extraction of sodium or manufacturing of sodium, and M4 is manufacturing of soap. Okay, so these are the processes M1, M2, M3, and M4. So identify the products P1 to P9. So we have identified all the products here. Briefly describe the steps involved in M1 and M3. So diagrams of equipment not required. So M1 and M3. So M1 is salt. So you can tell there are 3 tanks are used. So brief, okay. Tank 1, calcium carbonate get precipitated, and the rest is filtered out to tank 2. And in tank 2, calcium sulfate is precipitated and rest is filtered out to tank 3. And in tank 3, NaCl get precipitated, and the bittern or magnesium bromide, those things are removed from tank 3. That is a brief explanation, but don't forget these things are not now in your syllabus, so you don't have to worry much. And M3, what is M3? It is extraction of sodium. So you can simply explain this is happening electrolysis of the fused NaCl. So in anode, what is actually happening? Oxidation reaction. You can write down the oxidation reaction. In cathode, you can write down the reduction reaction, Na plus giving Na. Okay, so you can simply explain those two. Draw and label the equipment used in the process M2. So what is M2? So M2 is there in your syllabus. That is the manufacturing of sodium hydroxide. So you can draw this one, right? So in your syllabus, you have this, what is called the diaphragm cell, right? So you have this diaphragm cell in your syllabus. So you can draw this one. It's a nice diagram like this. So you have the perforated one, perforated cathode, and there is this anode compartment in the middle, right? So there is one chamber here and another chamber here to enter, and there is another chamber to add here and another chamber to exit. So there will be this big setup. And here in the perforated cathode, so you give the negative charge, and here there will be the positive part. I think I don't have to draw everything. You should know up to this point. And there is a carbon anode, so steel cathode, perforated cathode. So you have the anode compartment, and this is NaOH that you are going to remove from the system. That is how it formed. And here Cl2 is going to remove from here, right, from here. So you add here NaCl in the aqueous solution, and there is another compound to exit the hydrogen gas. So Cl to exit from here, H to exit from here, NaCl is going to add from here, aqueous solution, NaOH is going to taken out from here. So this is the normal diaphragm cell that you can draw. Okay. Identify the salt used in the process M3. So M3 is this one, the salt is calcium chloride. Give one use of each of P5, P6, and P9. So what is P5? So P5 is H2. So what you can write? So H2 is used in the manufacturing of margarine. Or you can write this is used as a fuel in rockets, P5. P6 is, what is P6? What is there? Give one use of P6. So P6 is sodium. So sodium is used in, you can say in sodium lamps even. You can simply write down this one. Sodium is used in sodium lamps, in the street lamps. Okay. P9. So P9 is actually glycerine. So glycerine is used in the manufacture of explosives like TNT. So you can write that. Okay. So this summarized our discussion, but the only industry that is important to you in this flowchart is this M2, which is the manufacture of NaOH, and M4, which is the manufacture of soap. Because this extraction of sodium as well as production of salt is not in your syllabus. In the current syllabus, there is no connection. Okay, but I prefer you to know all this because these are interconnected, right? Because they would like to just say NaOH production, but they also might ask you a question at your current syllabus. What type of other industries that can be combined to this thing? Then you can easily, or even they will ask, so to get NaCl and to add water and do this electrolysis to get NaOH, from where you can obtain this one, this NaCl solution. So you need to know this is from the salt production. You can get directly NaCl, right? So try to go through this and get a complete picture on it. Okay, so this finished our discussion on the part A of this question number 9. And moving on to the part number B. So answer this question using a list given below. So this is very simple, in fact. So we have given many things. So identify 2 gaseous species that are responsible for acid rain, and briefly explain with the aid of balanced chemical equations how. So we have discussed this many times. So you can use either NO, NO2O, or SO2. and you can write NO plus O2 giving NO2, and NO2 plus O2 plus water giving HNO3, and HNO3 decomposes into H plus and NO3 minus aqueous. So you can write down for either NO or NO2. Then same way for the SO2, you can write down SO2 plus O2 plus water giving H2SO4, and you can write down the decomposition reaction giving 2H plus aqueous and SO4 minus. So these are very simple things, right? Because they have us only two. Acid rain has harmful effects on it. So I have explained many harmful effects because of this in the previous explanation. So you can write down any of them, like harmful effects mean destroying plants, remove nutrients from the soil, make water hardness, make heavy metal accumulation high in water. So you can write many things. Okay. Identify 3 species that are emitted to the environment due to burning fossil fuel along with one adverse. So basically, the main is CO2, which is a greenhouse gas. So it will cause global warming. And NO, which will cause photochemical smog. And volatile hydrocarbons, which also can cause photochemical smogs. So you can write any of these, or even SO2 or NO2 that can cause acid rain. You can write any of these 3. The existence of trace amount of industrial synthetic species in the atmosphere can cause adverse environment effects. Yes. Explain this statement using CFC. So CFC, you know, this can be affect to either global warming or either even ozone depletion. So main thing is ozone depletion. The first thing that you can explain here is CFC is the persistence of CFC. Okay, so CFC is mainly used in refrigerators or air conditions. So it can emit these CFCs when you repair them or when you use them. And this CFC is persistent in the environment for longer times, and this can go to the upper atmosphere and then react with ozone, forming radicals. Even first you can tell this CFC can form radicals in the upper stratosphere and then react with ozone for its ozone depletion. So you can write down this depletion layer reactions even if you want. Okay, because they have not sentence like limited your sentence to like briefly or something, just explain. So try to explain very briefly, in fact, and with a comprehensive answer. That is important. Identify 5 greenhouse gases and state a human activity by which each of these gases enters to the atmosphere. Okay, so simplest, CO2, burning fossil fuel, and CH2, CH4 because of the animal husbandry, farming. And then you can write CFCs, which is from the air conditions, and SO2 even from fossil fuel, burning fossil fuel, and N2O from agricultural industry, and volatile carbons from transportation, and even H2S from anaerobic digestion. So you can select 5 and write down everything. Okay. Briefly explain using a biochemical equation how a natural substance selected from the list can be used to remove an acidic gas emitted during burning of fossil fuels. So we have to find something. So okay. So if you just think about the species that was given here and which one we did not use. We did not use up to now, like the liquid petroleum thing, coal or calcium carbonate. So think what is the usage of calcium carbonate. When you heat this calcium carbonate, you will get calcium oxide and carbon dioxide. All right, so this is a solid, this is a solid, this is a gas. So put the physical states. And for this one, calcium oxide, and they say to remove acidic gas, so you can send this SO2. So calcium oxide with SO2 gas, right? We have also seen this reaction before. Don't forget that. So this will form calcium sulfide. Okay. So this is the way it can be removed. This question was in the same way I have asked in the previous example, if you can remember what, in fact, I could remember this. I think this was in the extraction of iron, one of the raw materials that we use, limestone. They asked how can we use this one to remove gases as a leak. So this was the explanation for at that time also, right? So this summarize question number 9 as well. So there is not much of a hard thing that you can expect from this question number 9. The only thing is, this is the first point that you see after 2011 in the new syllabus, that they have given a flow diagram for industrial question. Because from 2011 to 2015, the trend is same. They have 1, 2, 3, 4, 5 question, ABCD questions, and you answer it in the perfect way. And this is the first time. So this trend was changed. I explained to you in the previous class also. This was one of the question. The trend was changed, and the other one was with the organic chemistry, the conversion. And these two are very, very common in the old syllabus, like from before 2011, from 10 to 2002. This is common, right?